sort of on the boundary with perhaps describing the physics of two problems, not at all this bridge, but mostly the sea and the atmosphere. So the problems I look at, so one of the problems I'm interested in is studying rogue waves, these really big waves, and specifically how they're affected by shear flows. You can have shear flows like here in the satellite picture, so where you have horizontal shear, and your social coordinator, James Steer, who was the year before you actually worked with me on a project where he looked at theoretical and experimental modelling of vertical shear, so looking at rogue waves on these shear flows. We do theory, we do experiments, and other things I'm interested in here are the evolution of internal and interfacial waves, so you can have these waves, but you can also have waves here that are driven by density differences, here in an ocean, in a bay, so the colour scale reflects temperature differences, and also in the atmosphere. So some of these waves that you can see here actually also occur because the atmosphere has density layers. So there's a lot of similar physics. And again, working with a combination of experimental and mostly theoretical methods. And thirdly, here some work on buoyancy-driven flow, and this actually ties in with the engine groups a little bit because they have all these injections into engines, and actually turns out lots of the turbulent physics is very, very similar to buoyancy-driven flow that you might have in the case of volcanoes. And then I think my time is almost up, but this is some new work I'm moving into. This is looking into the effect of waves and wave fields on particle transport. So you can think of particles as oil spill modelling, but also microplastics, lots of discussions on that. And there are lots of unanswered questions fundamentally about whether these pollutants are mixed and how that is affected by the rotation of the Earth and density stratification. So I work with mathematics here, and also some experimental work ongoing on trying to actually put these things into a real situation, into real flumes, and try to get a sense of the mixing that is associated with these particles as affected by waves and wave groups and actual statistical processes. And I think that's me done.
Thanks, Tom.
This production is brought to you by the University of Edinburgh.